Hi, in today's lecture, we will look into the different types of couplings used for connecting shafts. So, a shaft coupling is a mechanical device used to connect rotating shafts and also to absorb any misalignments between them. They can be rigid or flexible depending upon the type of alignment. So, they are used for transferring power and torque between one shaft and another shaft in motors, pumps, compressors, and generators. So this picture shows some pictures of. This slide shows some pictures of couplings. So why do we need a coupling? So power transmission is possible in parallel shafts by gear arrangement. So if we want to transfer power in shafts which are in a straight line, couplings can be used. So we can see how a gear transmits power between two shafts which are parallel to each other. And here we can see couplings which are used to connect shafts which are in a straight line for transmission of power. Some of the applications of couplings are: it helps to transmit power, it also helps to connect two components. It is used for extra flexibility while transmitting power in case there is a space restriction, and it is used to protect against overloads. It also reduces the transmission of shock load with the help of flexible type of couplings. So there are different types of couplings. We have the rigid and the flexible. So rigid are used when the two shafts are perfectly aligned. Flexible couplings are used when two shafts have both lateral and angular misalignments. So rigid couplings include sleeve or muff coupling, clamp, split muff or compression type of coupling, and flange coupling. Under flexible coupling, we have bush pin type, universal coupling, and Oldham coupling. So here we can see a sleeve coupling. So this is considered as a hollow cylinder. It is also called as a sleeve, inside which the driving shaft and the driven shaft will be connected, and holes are provided for bolts. A split muff coupling is similar to a muff coupling, except that it is split into two separate components which are connected using bolts, and a separate keyway is provided between the shaft and the coupling for perfect alignment. A flange coupling is when there are two components attached or two flanges attached between the driven and the driving shaft using nuts and bolts. So we have the flange and we have the hub. The flange is the larger diameter component, and hub is the smaller diameter component which is near the driving and the driven shaft, and we also have provision for the key. A bushed pin type of coupling is a coupling where you have bolts, and also you have a rubber bush provided surrounding the bolts for flexibility. A universal coupling is when you require to transmit power at 90 degrees or at different angles. So in universal coupling there is a lot of flexibility involved. An Oldham coupling is also used for transmitting power in at different angles when there is a misalignment or a lateral alignment between two shafts. So design of the sleeve or the muff coupling. So we have the sleeve coupling, and it is considered as a as a hollow cylindrical shaft, inside which you have the driven and the driving shaft, which is connected using a key. So the diameter of the muff or the coupling is capital D, and the diameter of the shaft is small d. So the outer diameter is equal to 2d plus 13 mm, 2d, where d is the diameter of the shaft. Length of the sleeve is capital L, which is equal to 3.5 times of the diameter of the shaft. So considering the torque equation, where the torque transmitted by a hollow section is T is equal to pi by 16 into tau into d power 4, capital D power 4 minus small d power 4 by capital D, where capital D is outer diameter and small d is inner diameter, we can consider the muff as a hollow section and use the same equation. So here we can consider K as inner diameter by outer diameter. So design for the key, it is also similar to what we have already seen. The length of the key is capital L by 2, where capital L is the length of the coupling. So, and then the torque equation with respect to the shearing stress and the crushing stress is written. So T is equal to LW into tau into D by 2, considering the shearing stress, and T is equal to L into T by 2 into sigma C into small d by 2, considering the crushing stress of the key. So next we can see the design of a clamp coupling. Similar to the muff coupling, here the diameter and the length equations are same. So here we can see that there are bolts additionally provided, and the length of the coupling is capital L, diameter of the coupling is capital D, the diameter of the shaft is small d. So you have clamps or bolts or studs which are used to connect both the muff and the shaft. So the design for the muff or the coupling and the key is similar to the previous coupling design, and only we need to design the bolts in addition to the existing design. So the existing so for designing the bolts, the force exerted on each bolt is calculated. So force is nothing but stress into area. So the stress is the tensile stress for the bolt material into the area of the bolt. So the bolt area is pi by 4 dB square. dB is the diameter of the bolt. And depending upon the number of bolts on each side of the shaft, we can consider a factor n by 2, where n is the total number of bolts. So now we can write the pressure equation, which is equal to force divided by area, where the force is already calculated, divided by the projected area. So the area where the bolts are in contact with the shaft, so it is half into L into D. So the frictional force between the shaft and the muff coupling is given as force is equal to mu into pressure into area, in which we can substitute the equation for pressure, and we can also substitute the equation for area. So here the area equation is pi d into L. So we can simplify the equation considering the pressure equation which we have already derived, and we can simplify the equation for the frictional force, from which we can calculate the torque equation. So the torque equation is force into the perpendicular distance. So here F is nothing but the frictional force which we have already calculated. Thank you.